The International Space Station is a state-of-the-art research laboratory that allows scientific research to be performed in the microgravity of space. Research conducted in this unique environment advances our knowledge of biology, chemistry, physics, and physiology. How do NASA scientists, researchers, and engineers work together using the most sophisticated technologies ever designed to bring about new discoveries that help improve our health and way of life on Earth?
Hi, my name is Jane Ginsler, and I work on the International Space Station program at the NASA Johnson Space Center. In my day-to-day work, I get to work with scientists and engineers who actually build hardware that flies to the International Space Station. Today, I'm at the Ames Research Center out in California, and with me, I have Dr. Sanjoy Som, who's going to be launching a really cool experiment to the International Space Station later on this year.
Hi everyone, my name is Sanjoy, and I have multiple jobs here at NASA Ames. On the one side, I'm a scientist studying life in extreme environments. On the other end, I'm an engineer working for the Fruit Fly Lab project, which is launching this fall to the International Space Station.
The Fruit Fly Lab 1 mission is the first flight of a research platform for long-duration experiments aboard the International Space Station using the widely studied model organism Drosophila melanogaster, or the common fruit fly. More than 70% of known human disease genes have a recognizable match in the genetic code of fruit flies. Studies of the flies have been used to investigate the roots of human diseases and disorders, from alcoholism to Alzheimer's. Unlike the human genome, the fruit fly genome is easily manipulated to create genetically different strains, which allows us to learn more about the effects of certain genes on behavior.
Hi everyone, welcome to the actual Fruit Fly Lab within the science laboratories at NASA Ames Research Center. This is my colleague, Dr. Hosamani. He is a scientist with the Fruit Fly Lab mission. Now we're going to show you the hardware that Dr. Hosamani's flies are going to be living in, and that we're launching this fall to the International Space Station. Come check it out.
The Fruit Fly Lab will house a system that has three major components. The first is the fly cassette that will house and safely transport fruit flies to the space station. The second is the food change-out platform that will be used periodically to provide the flies with fresh food while maintaining containment and allowing extraction of fruit fly eggs, embryos, and larvae for preservation. The third is the observation and lighting system to allow fly behavior monitoring and exposure to an artificial day and night cycle. The success of the Fruit Fly Lab mission requires the expertise of a team of scientists, researchers, and system engineers. They are responsible for making sure that the science requirements are translated to the engineering hardware, and that the engineering hardware is then qualified for flight to the International Space Station. Here's your challenge. Help the NASA team design and build an observation unit for the Fruit Fly Lab. Before the engineers can begin, they must consider the following constraints. The first constraint is that they have to reuse the house of the flies used in the 2006 space shuttle. This cassette is where the flies will be living for the duration of their mission in space. So they must build a unit that houses this same cassette. They must also be able to monitor the behavior of the flies in space. The team will need a camera with lights that simulate day and night cycles that the fly would live through if they were on Earth. This is called the circadian cycle. The hardware, with camera and lights, must fit inside the racks that currently exist on the International Space Station. So the dimensions of the box cannot be more than 3 times as tall as the cassette. Another important constraint when working with biological specimens in space is temperature. Flies operate best between 20 and 25 degrees Celsius. So the heat radiating from the cameras and the lights must be modified to ensure the flies do not overheat and remain alive. Next, the team must ensure that the system does not require a lot of power. The International Space Station uses solar panels for energy. However, all of the science and engineering that is being done on the station limits the amount of energy designed for each experiment. The final constraint is astronaut time. The old food contains larvae of the flies, which is critical and must be preserved for scientific examination on Earth. So the food change-out platform must be designed to allow the astronauts to change the food quickly and efficiently.
All right, so here's what we did. Let's start with our cassette. Remember, that's where the flies live, and we have our food tray inside. And like any engineering drawing, I need my axes. Excellent. And then we were constrained by the shape of the observation system, such that this can go inside, within which the house of the flies is inserted. Inside it, we're going to have our camera up there with a fisheye lens, such that the fisheye lens can capture the entire resolution, the entire space of where the flies are living. Now, in terms of lighting, remember I told you it was a bit tricky because we don't want to put bulbs that shine brightly onto the flies. So the way we did it, let me just redraw that same image up there, with the cassette here, is that we actually enclosed the bulbs on the underside so that they shine upwards, and put a mirror up here that then diffuses the light uniformly onto the flies. So that took quite a bit of trial and error. And also we have the camera there that's then filming the flies. And so in order to have the unit not warm up, we actually used software to integrate with the hardware that turns on and off the cameras at times, such that it doesn't get too hot in that. And that took extensive lab trial as well to see how long we can record before it gets too hot. The final constraint was to make it efficient and quick for the astronauts to remove the cassette, change the food, and put it back. Do you think we went with a solution that involved screwdrivers and a bunch of screws? No, we went with something little. I'm going to redraw the same thing in 3 dimensions to give you a better idea of what we did. Inside, we have the cassette. And so what we did is install hinges with our door and a little clip there, on the side of which we installed a stiff rubber band that's then fixed at the end, such that if you want to close the unit, you close the door, insert the rubber band, your observation system is shut. To open it, just unhook the rubber band and the thing opens, and then the cassette can come straight out and we can change the food. This is an efficient and simple way, and most importantly, safe way for the astronauts to use our system. Now, we have completed all our testing, and our experiment can then operate safely on the International Space Station, is safe for the astronauts, can survive the shake of the launch vehicle as well as the return, and will guarantee the maximum science from the scientific requirements that were given to us by the scientists.
How does your solution compare with NASA's solution? NASA is an independent agency of the executive branch of the United States federal government responsible for the civilian space program, as well as aeronautics and aerospace research. NASA civil service employees are responsible for conducting aerospace research and development, managing resources, and operating our NASA facilities. Aerospace engineering and operations technicians operate and maintain equipment used in developing, testing, producing, and sustaining new aircraft and spacecraft. Increasingly, these workers are using computer-based modeling and simulation tools and processes in their work, as well as advanced automation and robotics.
It is very important for us engineers to talk to the scientists regularly to make sure that their hypotheses that they are testing on the space station is captured by my engineering hardware. So I just want to emphasize that when you're in school, it's not only about the academics, right? Learn how to communicate with your colleagues, because that's going to be extremely important in your professional career.
Computer hardware engineers research, design, develop, and test computer systems and components such as processors, circuit boards, memory devices, networks, and routers. There are a variety of fields of study to jumpstart you into a career at NASA. Physics, earth and planetary science, and engineering. If you like solving challenges like this, consider careers like the ones offered at NASA: aerospace engineer, computer engineer, systems engineer,